Example 28. Given y equals to e to the power of negative 2x times cos 3x, prove that d2y over dx squared plus 4 times dy over dx plus 13y equals to 0. In this question, we need to prove the expression here equals to an answer 0. So, we need to find the first part, what is dy dx, and the second part, what is d2y dx squared. For our equation y here, it is in the product of two functions, where the first function is e to the power of negative 2x, and the second function is cos 3x. First, we will find dy dx by using product rule. Let u equals to the first function e to the power of negative 2x and v equals to the second function cos 3x. Differentiate u with respect to x equals to, copy back the exponential function, then differentiate its power negative 2x equals to negative 2. Simplify the answer equals to negative 2 times e to the power of negative 2x. Then we differentiate v with respect to x. Differentiate cos 3x equals to negative sin 3x. Then differentiate the function 3x equals to 3 equals to negative 3 sin 3x. dy dx equals to u times v prime plus v times u prime. Next, we are going to simplify the dy dx answer by factorize out the common factor e to the power of negative 2x. Then, we are going to calculate the remaining factor from the front part. And from the back part, let us continue to the second part of this question, which is we are going to find d2y dx squared. In order to find second derivative of y, we have to differentiate it from the first derivative of y, which is dy dx. In our equation of dy dx, it is in the product of two functions, where the first function is e to the power of negative 2x, and the second function is negative 3 sin 3x, negative 2 cos 3x. So, first, let u equals to the first function e to the power of negative 2x. Then v equals to the second function negative 3 sin 3x minus 2 cos 3x. Differentiate u with respect to x equals to, copy back the exponential function and differentiate its power negative 2x equals to negative 2 equals to negative 2 e to the power of negative 2x. Then we differentiate v with respect to x equals to negative 3. Differentiate sin 3x equals to cos 3x. differentiate its function 3x equals to 3 minus 2, differentiate cos 3x equals to negative sine 3x. Then differentiate its function 3x equals to 3. Simplify the answer equals to negative 9 cos 3x plus 6 sine 3x. Now, we are going to find our second derivative of y by using product rule. U times b prime plus v times u prime. Then we are going to simplify our answer by factorize out the common factor e to the power of negative 2x. So now we're going to calculate the remaining factor from the front part equals to negative 9 cos 3x plus 6 sine 3x. From the back part equals to negative 3 times negative 2 equals to positive 6 sine 3x. And negative 2 times negative 2, positive 4 cos 3x. Lastly, we simplify our answer. Negative 9 cos 3x can be operated with 4 cos 3x to give us answer equals to negative 5 cos 3x. Then 6 sine 3x plus 6 sine 3x equals to 12 sine 3x. Let us continue the part 3 of this question where we need to find this equation equals to 0. So we will substitute the result from previously, which is for d2y dx squared equals to e to the power of negative 2x minus 5 cos 3x plus 12 sine 3x plus 4 times the result of dy dx e to the power of negative 2x times negative 3 sine 3x minus 2 cos 3x and plus 13y. Y is our original equation, which is e to the power of negative 2x times cos 3x. Now, notice that we have 3 parts here. First, second, and third. These 3 parts, they have the same common factor, which is e to the power of negative 2x. So, we will simplify it by factorize it, e to the power of negative 2x. Then, the remaining factors are negative 5 cos 3x plus 12 sine 3x from the first part, then plus 4 times negative 3 become negative 12 sine 3x. 4 times negative 2 becomes negative 8 cos 3x. This is from second part. And plus 13 times cos 3x, which is 13 cos 3x. This is from third part. So notice that for sine 3x, it can be simplified out equals to 0. For cos 3x, here we have negative 5, here we have negative 8, and lastly we have 13. Also, we can simplify it to become 0. Therefore, e negative 2x times 0 equals to 0. Lastly, we managed to prove this equation equals to 0.